Hi, good afternoon to everyone. In the last session, we have focused on these algorithms, finding the factorial of the given integer, solving the quadratic equation, and we have designed the algorithm to find the product of first n natural numbers. That is, product is equal to 1 into 2 into 3 into etc. n. Hope you have gone through this session. Have any doubts in the last session? We have any doubts in the last session? Harita, Manasha, Vigneshwaran, Varshini, Pooja, and what about others? Ramkumar, have any queries?
No doubt, sir.
No, sir.
Okay.
Sir, my name is
Now,
Vasudhajit, sir. Ramkumar is my father's name, sir.
so okay. Vasudha Ji, no problem. Good. In this session, we focus on how to find the sum of first n natural numbers, and then we see given the integer n, finding the sum of the digits of the given integer, then see how to reverse the given integer. Just to have a look into this flow chart, we have implemented using while loop, that is designed here while I is less than or equal to n. This is same as using the statement for I is equal to 1 to n. Both are same. For I is equal to 1 to n means initial value of I is 1, it checks the condition if I is less than or equal to n. For loop, for I is equal to 1 to n, then writing product is equal to product into I, then incrementing I by 1, I is equal to I plus 1. For example, semicolon, or you can write as it is. These are the statements that we have written inside the while loop, while I is less than or equal to n. Precedingly, we have controlled these statements through the while loop, while I is less than or equal to n. That means as long as the condition I less than or equal to n is true, we need to execute these statements. While is the same as the for loop, for I is equal to 1 means how it works. Initial value of I is taken as 1. The upper bound value of I is n, last value of I is n. I is 1, this is the starting value. This is the stopping value. So for each value of I, we need to check if I is less than or equal to n. If I is less than or equal to n, then the control enters into this part of for loop. As we designed earlier, right, while I less than or equal to n, the condition is true, control goes to execute these statements sequentially. So the thing is, while I less than or equal to n, this can be written as for I is equal to 1 to n, both are same. So when I is equal to 1, it checks the condition I less than or equal to n. Same as checking the condition here I less than or equal to n. After that, here product into I is incremented by 1. Then it checks the condition again if I less than or equal to n. The condition is true, then only it enters into the for loop. Similar to for loop, while loop, right? When the condition becomes false, control comes out of the while block. Same way here. When I less than or equal to n, condition is false. Control comes out of the for and it executes the next executable statement following the block of for state. So keep in mind that in the last class we have designed right the logic using for loop, while loop, while I less than or equal to n. This can also be written as for I is equal to 1 to n. Then you can write in terms of steps. This is the next step and this is the next step. For I is equal to 1 to n, execute steps, subsequent steps. Or while I less than or equal to n, execute the next two steps sequentially. Hope you understand. In this session, we focus on first this problem, finding the sum of first n natural numbers 1 plus 2 plus 3 plus etc. n. How to evaluate s is equal to 1 plus 2 plus 3 plus etc. n, where n greater than 0. This is the integer, positive integer. Let us write the algorithm. How do we write the algorithm? Step 1, start. Step 2, what is the input required? N greater than 0. This integer is required as the input. So write input n. N is greater than 0. N is input n. This is greater than 0 and integer 1. Then we need to control through the while loop or for loop. So let us initialize one variable. For example, here I set s is equal to 0 because the variable s holds the sum of first n natural numbers. So I am initializing the value of s to 0. Then in step 4, I write for I is equal to 1 to n. Then in next step, step 5, let us evaluate s is equal to s plus I. Then step 6, print s. Step 7, stop. Step 8, end, terminate the execution. This is the algorithm to find s is equal to 1 plus 2 plus 3 plus etc. n. Have a look into these steps. These are the well-defined instructions. As you start with getting the positive integer n, setting the sum value to 0 initially. For I is equal to 1 to n, this is same as right this conditional construct, or while I is less than or equal to n. How long we need to execute, or we need to tell what is actually contained in this step for I is equal to 1 to n. For I is equal to 1 to n, right? This is controlled with this step, step 5, s is equal to s plus 5. So I have written some indent space here to indicate this is the executable step or statement coming under this path. Or you can write for I is equal to 1 to n. What you have to do, you can execute step 5. Execute step 5. That means for each value of I, execute this step 5. Or you can write step 5 can be cut. You can write s is equal to s plus 5 as a part of step number 4. Then you can write print s, then stop n. How will be the flow of execution? Let us trace right so that we can find. Since s is equal to 1 plus 2 plus 3 plus etc. n, we are controlling one variable I. This is the value of I. I starts at 1, I ends at the value n. Initializing s is equal to 0. If we move from left to right using the variable I, where I ranges from 1, 2, 3, etc. n. When I is pointing the first number 1, we are updating right current s with this 1. So that here we have 0 plus 1 is equal to 1. This 1 is updated in the variable s. So s is equal to 1. Next, when we move I to point the next integer 2, current s and I, that is 1 plus 2. This is 3. 3 is updated in the variable s. S is 3. That means the sum of first two integers is 3. Then when I is pointing the next integer 3, I is equal to 3. Sum is updated to current sum. Current sum is 3 plus current I is 3. 3 plus 3, 6. So s updates to 6, which means that this is 1 plus 2 plus 3. Previously 3, this means this is 1 plus 2. Here s is equal to 1 means simply 1. So when n is equal to 1, 1 is assigned to the variable s. When n is equal to 2, last integer is 2. 1 plus 2, 3 is assigned to the variable s. When n is equal to 3, 1 plus 2 plus 3 is evaluated and the result is assigned in the variable s. So using induction, when I reaches this case, I reaches n. When I is equal to n, clearly s holds 1 plus 2 plus 3 plus etc. plus n. That means the sum of first n natural numbers is obtained and the result is updated in the variable s. Understand? Sanjay, what is the doubt? Sanjay, understand the logic of this algorithm. Have any doubts in this?
No, sir.
Okay, I do the trace for one sample value. Suppose n is equal to 5. In step 1 start, step 2 n5, step 3 s is equal to 0. So here you do like to trace like this. Initial value of I, checking if I is less than or equal to n, then updating a variable s. What is the initial value of I? Initial value of I is 1. Initial value of s is 0. Now when the control enters into step 4, I starts at 1. When I is equal to 1, it checks if I less than or equal to n is true. When I is equal to 1, since n is 5, 1 less than or equal to 5 condition is true. In this case, S is updated to, or I write here, S is equal to 0 initially. Now S is updated to S is equal to S plus I. Understand the meaning of this instruction, S is equal to S plus I. This means that the variables S and I are added together and the result is again updated in the variable S. That means current S is 0 plus current I is 1, 0 plus 1, 1. 1 is stored in the variable S. So I am not writing S is equal to 1. The meaning is like that is S is equal to 1. Understand? Next, what happens? For I is equal to 1 to n means execute step 2. By default, the next value of I is incremented by 1. That means I is equal to I plus 1. Because of this, I becomes 2. 1 plus 1 is equal to 2. Then checking if the condition current I less than or equal to n. 2 less than or equal to 5 condition is true. Now S is equal to S plus I is executed. Current S is 1 and I is 2. 1 plus 2 is equal to 3. That means S assigns the number 3. Next, I is incremented by 1. I is equal to I plus 1. 2 plus 1. This is 3. Checking the condition if I less than or equal to n. 3 less than or equal to 5. Condition is 2. Now update a value of S. S is equal to current S is 3 plus current I is 3. 3 plus 3 is 6. That means S is updated to 6. Then I needs to be incremented by 1. I becomes 3 plus 1 is equal to 4. 4 less than or equal to 5. Condition is true. Then S is updated. Current S is 6 plus current I. What is current I? This is 4. 6 and 4 are added together. The result is 10. S stores 10. Next, I is equal to I plus 1. 4 plus 1, this is 5. Condition is true. 5 less than or equal to 5. This condition is true. Now updating a value of a variable S. What is current S? Current S is 10 plus the current I is 5. 10 plus 5 is equal to 15. S is updated to 15. Next, I is incremented by 1. I is equal to I plus 1. Next, I is. What happens? 5 plus 1 is 6. 6 less than or equal to 5. Condition is false. Good. Now the control comes out of step number 4. Ultimately, step 5 will not get executed. Step 5 is executed each time when the condition I less than or equal to n is true. That's what previously we have written the same for loop using the while loop as while I is less than or equal to n. Both are same. So as long as the condition in the while remains true, executes to true, part of while statements are executed. Likewise here, when I less than or equal to n is true, S is equal to S plus I gets executed. If the condition is false, control comes out of the for and the next sequential executable statement is this one, print yes. Now what happens? We are coming out of step number 4 and 5 because the condition has been false, has become false. Now in step number 6, printing yes. Now print yes. Current value of is. What is the current value of is? This is 15. 15 is printed. This 15 is actually 1 plus 2 plus 15 is equal to 1 plus 2 plus 3 plus 4 plus 5. That's what, right? We have n into n plus 1 by 2, 5 into 6 by 2, 30 by 2, 15. So the sum of first n natural numbers is obtained and finally stored in the variable yes. This is the logic to find the sum of first n natural numbers using either a for loop or even you can use the while loop. For I is equal to 1 to n, this can be changed as while I less than or equal to n. Both are the same. Understand the logic? This is same as right what we have designed earlier. In earlier, right, we have find the product of first n natural numbers. Using while loop, we have written as product is equal to product into I, because we need to find the multiplication of the numbers. For multiplication, the resultant variable, say product is initialized to 1 and the multiplication operator is used. In case if this is a sum, instead of multiplication, say here plus 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 etc. plus. In that stage, what we have to do, we need to replace the multiplication. Sorry, replace the multiplication by addition. So having the variable yes to hold the sum, we have written as s is equal to s plus I plus, right, performs addition here, so that the initial value of s is set to 0. Finally, whatever is the value of n into n plus 1 by 2 is evaluated and the result is assigned in the left hand side variable yes, and it gets printed. This is the logic, right, to find the sum of first n natural numbers. Have any doubts in this algorithm? Shall we pass on
No,
to
sir.
the next one?
Yes.
Okay. Yeah, we are passing on to the next example. Please take it. Before going to reverse the given digits of the number, I do like to solve this exercise first. So the next problem is find the sum of the digits of a given integer. Say n. Assuming that the given integer n consists of some fixed number of digits, we need to find its sum. For example, n is equal to 12. We do like to find the sum as 1 plus 2 is equal to 3. This is expected. Suppose n is equal to 1, 2, 3. We are expecting the sum as 1 plus 2 plus 3. 6 is expected. N is equal to 100. Sum is expected as 1 plus 0 plus 0 is equal to 1. This is the problem. To find the sum of the digits of the given a positive integer n. we need to devise the logic, or we need to devise the pseudo code, algorithm, a flow chart to solve this problem. So to solve this problem, for example, if we take n is equal to 1, 2, 3, first I tell you the logic, then we can formulate this logic as an algorithm easily. Equivalent right pseudocode or flowchart can be prepared right easily. When n is equal to 1, 2, 3, we need to find the sum is equal to 1 plus 2 plus 3, 6, right? We need to bring this quantity. That means we need to separate the digits 1, 2, 3. The number consists of the digits 1, 2, 3. The problem is, how do we extract these digits 1, 2, 3? This is actually brought here 1 plus 2 plus 3. Hope you understand. Since n is 123, for example, 3 is the last digit in that number. To find out the last digit in this number, we can find the modulus operation, modulo or modulus operation. We have already discussed, right, the modulus operation. For example, if the modulus operator is percentage. Since percentage is the modulus operator in C language, let us try to use this operator to indicate the modulus operation. So when 123, that is, I write in short mod MOD, or you need to use percentage, whichever is. 123 mod 10, dividend is 123, divisor is 10. When 123 is divided by 10, what happens? 123 is divided by 10. Quotient is 12. 12 into 10, 120. Remainder is 3. This is the quotient. This is the remainder. So 3 is obtained by performing the modulo 10 or modulus 10 operation. This results in 3. So this 3 is obtained here. 3 is obtained here. Once we obtain the digit 3, we can sum it, or we can update the variable sum. So set initially, say the variable sum s is equal to 0. After finding one digit, update a variable s. S is equal to say 0 plus 3. S gets updated to 3. Next, from 123, this is the 123. 3 has been extracted in 123. The digit 3 is extracted. You have to extract the digits 1 and 2. 3 has already been extracted. So the current value of n is 123. When 123 is divided by 10, 123 is divided by 10. What happens? 123, 10. 12 tens are 120. Remainder is 3. What about the quotient? Quotient is 12. So 123 by 10, this results in 12. We can update the variable n to point to this operation. So if we write n is equal to just n by 10, this is n. N is equal to n by 10. N gets updated to 12. Previously, n is 123. We performed 123 modulus 10. the last digit, unique digit is extracted and the result some variable gets updated. Now currently, because of n is equal to n by 10, in this case, n is pointing the integer 12. Once again, if we perform sum is equal to sum plus say n mod 10. In this case, previous sum is say 3, n mod 10, 12 mod 10, 12 mod 10. When 12 is divided by 10, further 1 into 10, 10, remainder is 2. This is the remainder, this is a quotient. So 12 mod 10, this results in 2, 3 plus 2, 5. This is updated in the variable. Yes. Next from 12, right, we need to extract the digit 1. That means now the digit 2 has been processed here. So iteratively perform this operation. N is equal to n by 10. 12 by 10. When 12 is divided by 10, the quotient is 1. So that we will get 1. When n becomes 1, then perform this operation. S is equal to S plus n mod 10. Current S is 5 plus 1 mod 10. Dividend is 1, divisor is 10. 1 mod 10 results in 1. 5 plus 1 is equal to 6 is updated in the variable S. Then n is updated to n by 10. 1 by 10 means this is 0. Right? Quotient is 0. So when n becomes 0, as long as n greater than 0, please repeat these operations. What are the operations? Finding the modulus value, updating the sum variable by adding the remainder, then dividing the value of n by 10, updated value of n is checked again in the for loop or while loop. So this way, this iterative logic can be implemented in the for loop or while loop. For example, here let us implement using the while loop. Here I write the algorithm first.
Sir,
Let us trace next. Yes. Yes.
sir, can I explain this again?
Vigneshwaran, tell me your problem.
Sir, can I explain this again, sir?
Which one? This example.
Yes, sir.
Okay. See, to find out the digits of the given number, you need to extract the digits. Suppose n is 123 means the digits are 1, 2 and 3. To find out the last digit, right, you can see in one's place the digit is 3. That is said to be the unique digit. To find out the unique digit in any given integer, simply find the modulus operation, modulus 10. 123 modulus 10, that results in the remainder 3 after performing the integer division. Please check it right in the first class itself, right? We have covered what is the modulus operation. You need to understand that first. So 123 mod 10 results in 3. The last digit 3 is extracted. And 3 gets updated with the variable S. Then from 123 we need to extract the digits 1 and 2. So we are expecting the digits or extracting the digits from right to left direction. 123 right to left direction. First 3 is extracted, then 2 will be, then 1 will be. So in that case, when 123 is divided by 10 further, 123 by 10 results in 12. So from 12 we can find 2. To find 2 from 12, again perform modulus 10 operation, 12 mod 10, 2 is extracted. Then from 12, right, 1 needs to be extracted. For that, first divide 12 by 10. 12 by 10 becomes 1 as the integer division. Quotient alone be stored, right, updated in the variable n. Don't say write 1.2 or 12.3, right? That is not the case here. This is just storing the quotient, right, into the left hand side variable. So 12 by 10, not 1.22, 1 is stored in the left hand side variable n. Once again, if you check if n is greater than 1 and perform modulus 10, we have here 1 mod 10. This results in 1. So 5 plus 1, 6 gets updated into the variable yes. Next, if we perform, right, n is equal to n by 10, 1 by 10 becomes 0. 1 by 10 is not 0.1 because when 1 is divided by 10, quotient is, right, what is the quotient? Quotient is 0, remainder is 1. We are taking the integer, right, the quotient 1. That case, n becomes 0. So when n becomes 0, you need to come out of that logic and store or print whatever you have currently in the variable yes. This is the logic, right? Iterative logic. Repeatedly we are performing the operations until the value of n becomes 0 or as long as n greater than 0, right, it remains true. Clear? Vigneshwaran, clear?
Yes, sir. Thank you, sir.
Okay. Now this process we are trying to write in the algorithm. So in the pseudocode, what we have to write? We can write simply read the value of n, perform right modulus 10 operation, update a variable yes, divide the value of n by 10 and update n. Repeatedly apply these operations until n becomes 0. These are the few lines to be written as the pseudocode for this problem. So once this has been written, we can, or once this logic has been read, understood, we can easily convert this logic into the algorithm, right? We have solved, right, several problems. Please listen, right, how we are writing the algorithm to solve this problem. Step 1, start. Step 2, input n. Algorithm, right, after that if you want, you can write the name, sum of the digits. For example, you can write like this, algorithm colon, sum of the digits of n. Okay, this is the name of the algorithm. Step 1, start. Step 2, input n. Then step 3, we need to initialize the sum variable. Here we have initialized s is equal to 0. So I am writing this initialization here. Set s is equal to 0 or sum is equal to 0, whatever is. Final result is stored in the variable s. S holds the sum. You can write sum is equal to 0 or in a simple variable, one letter, s is equal to 0, whatever is. Then step 4, please understand, we have performed the operations of modulus and division. Modulus 10 and division 10. How long we have carried out? until n becomes 0. So when n becomes 0, here s holds 6, all digits are summed, right? And the result is assigned in the variable s. So we can write the logic, for example, while n is greater than 0. While n greater than 0, we need to perform some steps. So I can make the indentation, just leave some space to indicate those statements are part of while. Or we can write those statements in step 4 itself, whichever is convenient to you. Now s is equal to s plus n mod 10. This is returned, and the value of n by 10 is updated, right? Here this is s is equal to s plus current s is, this is current s, this 3 is nothing but current n modulus 10. So I write s is equal to s plus n mod 10 as a first executable statement of this while. Leave some space, write s is equal to s plus, I put colon here, s plus n mod 10. Precedence, priority, right? You might have seen Bodmas books. Division, right here, modulus operation. N mod 10 is evaluated first, and then the result is added with the variable s. Don't think this as s plus n is evaluated first and then modulus operation is carried out. That is wrong. S plus n mod 10 is, n mod 10 is evaluated and then s is added to update a variable s, or this is equivalent to s plus within bracket n mod 10. This bracket parenthesis is actually not necessary because of operator precedence. Then in step 5 over, okay. Step 6, we are updating the value of n as n is equal to n by 10. These two are actually the part of while block statements. S is equal to s plus n mod 10, n is equal to n by 10. One stage when n becomes 0, while loop condition is false. When the while loop condition is false, control is transferred to execute step number 7. Here write indentation, right? Save W column. Here I write print yes. Then step 8, we can stop. Step 9, terminate the flow of execution. Step 9 in. The important thing is how long we need to execute these statements. That is defined here in the while loop simply. While n is greater than 0. S is equal to s plus n mod 10 is first executed. Then n is equal to n by 10 is executed. First I show, right, with one trace so that we can understand this execution further better than seeing these two slides. Seeing these two slides, right, you will not get a clear understanding. But when we do the trace, right, for these 9 steps, you will understand clearly. For example, we are taking the value n is equal to 768, a 3-digit number. To do the trace, we can construct some columns so that you need not write these steps again and again. Just have a look into here. S is equal to s plus n mod 10 is returned. Again here s is equal to s plus n mod 10 is returned. Here s is equal to s plus n mod 10 is returned. So several times, right, you need to write these steps. N is equal to n by 10, s is equal to s plus n mod 10. So I am simplifying this into some column-wise calculations. You understand, right, easily. First, checking the condition, n is greater than 0. N greater than 0. This is one condition, column. Then s is equal to s plus n mod 10. This is another column. S is equal to s plus n mod 10. Another column. Another column needs to be constructed. Right? Say n is equal to n by 10. N is equal to n by 10. Have a look into these columns. Initial value of n is say 768, and setting the initial value of s as 0, because in step number 3 itself, before we execute step number 4, we have initialized s is equal to 0. For example, I write initial value of n. This is initial stage. Now, please understand, we are in step number 4. The condition to be tested is while n is greater than 0. That means we need to check if n is greater than 0, and then the condition results in true. We need to perform two sequential operations. So checking the condition n greater than 0, this is the first step. N greater than 0. I am checking here, is n greater than 0? 768 is greater than 0. Condition is true. I put a tick mark, right, to have the result as true. If this is true, while block instructions are executed. These two are the while block instructions which are executed sequentially, one after another. First, s is equal to s plus n mod 10. S is equal to s plus 0 plus current s is 0. I evaluate the right hand side. N mod 10. N mod 10 is 768 mod 10. 768 mod 10 means this is 8, because 76 is the quotient, 8 is the remainder. So I write this is 0 plus 8 is equal to 8. Please understand, this 8 is stored in the variable column heading. Left hand side variable yes. Here also the left hand side variable n. So whatever we are writing below this column, these are stored in the variables s and n respectively. After s is equal to s plus n mod n, n needs to be updated, because next step, n is equal to n by 10. N is equal to n by 10, 768 divided by 10, not 76.8, taking the quotient 76, this means 76 is the new value of n. Please understand. So we have updated two variables. One is s and another one is n. Next, after the execution of steps 5 and 6, or here you can write while n greater than 0, what you can write? Execute steps 5 and 6. This is another way, right, to have the clarity of steps 4, 5, 6 execution. While n greater than 0, execute steps 5 and 6. Or you can write execute steps 5 and 6 while n is greater than 0. All are same. Now 5 and 6 are executed. Then again control goes to check the value of n greater than 0. That is the purpose of while loop. Now checking if n is greater than 0, updated value of n is 76. I write here 76 is greater than 0. Checking if 76 is greater than 0, yes, condition is true. Now s is equal to s plus n mod 10. Current s is 8, right? What is that 8? This one, this 8 plus n mod 10, 76 mod 10. 76 modulus 10 means either you write mod 10 or percentage 10, right? 76 mod 10 returns a value 6. 8 plus 6, 14 is updated in the variable yes. Then n gets updated n by 10. Current n is 76 by 10, not 7.6. 7 is stored in a variable n. N is updated to 7. Then next stage, checking if 7 is greater than 0, condition is true. S is equal to s plus n mod 10. Current s is 14. I write here 14 plus n mod 10, 17 mod 10. We know that x mod y is x if and only if x is less than y. So 7 mod 10 results in 7 because quotient is 0, remainder is 7. 14 plus 7, 21. Then n gets updated to 7 by 10 is equal to 0. This is the updated value of n. Then control enters into step 4 to check while n greater than 0 is true. Now n is 0, 0 greater than 0. What happens? Condition is false. 0 greater than 0, condition is false. So when the condition becomes false, control comes out of the steps 4, 5, 6. Next sequential executable step is step number 7, print yes. So false. After that, therefore, the next executable step is well-defined instruction. Print the value of yes. What is the final value of a variable yes? This is the final value of a variable yes. S is equal to 21. That means 21 is output. 21 is actually 7 plus 6 plus 8. So sum of the digits of the given integer n is stored in the variable yes. So clearly this algorithm is working correctly. So for any positive integer n, clearly these 9 steps work correctly to find out the sum of the digits of that integer. Hope you understand. So you try to do right the trace for some other example. You can ask, sir, what about 106? 0 is there in between first and last. Or what about when n is 1000? When n is 25,007? Whatever is the digits, right? 0 to 9, no problem. The algorithm correctly produces the result to find the sum of the digits of the given integer. So in case if you put n is equal to 100, as we have seen earlier, expected result will be 1 plus 0 plus 0, right? You will check, verify, 1 will be the result. Suppose n is equal to 505, you can find the result n is 5 plus 5. 10 will be stored after the trace. 10 is stored in the variable yes. Hope you understand this problem. Finding the sum of the digits of the given integer. Once you understand this, next we can write a logic or pseudocode to find the reverse of the given number. Suppose n is 123. We need to reverse the number as 321. N is 768. We need to reverse the number as 867. N is 507. The reverse of 507 is 705. N is 100. Reverse is 001. Simply 1. So understand the logic, right? How we designed using modulus and division operations repeatedly to find out the sum of the digits of the given number. Understand this problem? Do you have any doubts?
No, sir.
Others, if you have any doubts, you can ask. You do one thing to try to do the trace, right, of all these algorithms, right, whatever we have discussed, by taking some other value of n. Say here you can take n is equal to 8, do the trace. For product of n numbers, take n is equal to 7, check if 7 factorial is obtained. Here try to take n is equal to some 4-digit integer or 5-digit integer. Do the trace by constructing these necessary columns, right, as we have done here. These are the column headings, so that every stage you need not write s is equal to s plus n mod 10, n is equal to n is equal to n by 10. These things and all not necessarily written, just a column heading. Column heading, right, Lagrange variable. Whatever the value you are writing in that column, that is the actual value of that left-hand side variable. So based on this, right, if you have traced, right, for some other values of n, you will realize, you will find a logic to transfer to reverse the digits from 768 to 867. Just think of how to bring 8, right, as the first digit, 6 as the second digit, and 7 as the third digit. Not only for a 3-digit number. Suppose n is equal to 1, 2, 3, 4. We need to reverse it to 4321, 4321. Whatever is the number of digits, we need to design the correct logic so that the digits should be reversed without affecting its meaning. So just think of, right, and try, right, the steps. Try yourself. How do we reverse the digits of a given integer? In next session, right, we will focus on reversing the digits of the given number, and then, right, we proceed further. So if you have any doubts right now, you can ask. Okay, thank you very much. Please go through the session. I will update, right, the materials, post the materials after some time. Go through, right, both these things, slides, right, return materials, as well as the video, so that you will get a clear understanding, and post your comments, right, in case if you have doubts, right, please post it. We will see tomorrow. Prepare well. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.